Hello everyone, here Dr. Zahid Ansari, Professor Department of Computer Science, PA College of Engineering, Mangalore, Karnataka, India. In this video, I am going to discuss the basic concepts related to multithreading in Java. We'll be covering multitasking, process-based multitasking, thread-based multitasking, also called as multithreading. Then why multithreading is required, a thread's lifecycle model, what is thread's priority, what is thread synchronization, and the thread class in Java. What is multitasking? Multitasking allows a user to perform more than one computer task at a time. There are two kinds of multitasking: process-based multitasking and thread-based multitasking. What is process-based multitasking? A process is an instance of a computer program that is being executed. It contains the program code and its activity. Process-based multitasking is about allowing several programs to execute concurrently. For example, a Java compiler and a text editor being run simultaneously. Processes are heavyweight tasks. They require their own memory address space, and the inter-process communication between the processes is expensive and it is limited. Also, the context switching from one process to another is expensive and limited. Then what is thread-based multitasking? A thread is a path of execution within a process. A process can contain multiple threads. A thread is also known as lightweight process. Thread-based multitasking is about a single program executing concurrently several tasks. Example, a text editor, printing and spell checking the text simultaneously. Threads are lightweight tasks. They share the same address space. They cooperatively share the same process. Inter-thread communication is inexpensive, and the context switching from one thread to another is at a low cost. Java supports the thread-based multitasking. What is the reason for going for multithreading? Multithreading enables us to write efficient programs that make the maximum use of the CPU, keeping the CPU idle time to a minimum. Multithreading is necessary because there is a plenty of CPU idle time for interactive network applications. The transmission rate of data over a network is much slower than the rate at which the computer can process it. The local file system resources can be read and written at a much slower rate than can be processed by the CPU, and the user input is much slower than the computer processing. Therefore, for most of the time, the CPU is idle when these tasks are happening. So, to utilize the CPU idle time, it's good that if we go for the multi-threading, so that some other task is being executed by the CPU at that time. The idea is to achieve parallelism by dividing a process into multiple threads. For example, in a browser, multiple tabs can be different threads. MS Word uses multiple threads. One thread to format the text, another to process inputs, etc. Now we'll see a thread's life cycle model. When a thread is created, it goes into new state. A new thread begins its life cycle in this state and remains here until the program starts the thread. When the program starts the thread goes into runnable state. So once a newly created thread starts, it goes into the runnable state. And it remains in this state until it actually starts executing its task. That is, when it executes the run method. The thread goes into the running state. When it actually starts executing it, it's passed by entering the run method. It may go back to the runnable state by using the yield method, which can send it back to the runnable state. A thread may go to the waiting state. A thread enters in the state where it is temporarily inactive. That is, it is still alive, but it is not eligible to run. And this happens when a thread is waiting for something, or sleeping, or it's blocked. And finally, the thread goes into the terminated state. A thread enters the terminated state when it completes its task, or otherwise it gets terminated. Now we'll see what is thread priority. Since multiple threads, they compete for the CPU time, so every thread is assigned a priority. That is an integer number to decide when to switch from one running thread to the next thread, called context switching. There are certain rules for context switching. A thread can voluntarily relinquish control by sleeping or getting blocked on input-output. In that case, the highest priority ready-to-run thread is given the CPU. A thread can be preempted by a higher priority thread. In that case, a low priority thread is suspended. When two equal priority threads are competing for the CPU time, then which one is chosen, that depends on the operating system. Next, we'll see what is thread synchronization. Multithreading introduces asynchronous behavior to a program. How to ensure synchronous behavior when we need it? For instance, how to prevent two threads from simultaneously writing and reading the same object. Java provides the implementation of monitors so that the classes can define so-called synchronized methods. Each object has its own implicit monitor, and that is automatically entered when one of the object synchronized method is called. So once a thread is inside a synchronized method, no other thread can call any other synchronized method on the same object. This way, the shared objects can be protected from being simultaneously written. Next, we'll see the thread class in Java. The whole Java multithreading environment is based on the thread class. Thread class encapsulates a thread of execution. To create a new thread, a program extends the thread class. That is, it inherits the thread class, or it implements the runnable interface. The details of thread creation we'll see in subsequent videos. For now, we finish our discussion about the basic concepts related to Java multithreading. Thank you very much.